Okay, so I will revise with you the general binomial formula first. As you will learn last week, the binomial formula is actually symmetric. And what do I mean by this? You don't have to purposely memorize the formula. All you need to do is to see that, okay, the expansion follows such. So x to the power of 0, then y to the power of 4, then plus 4 choose 1, x to the power of 1, y cubed, plus 4 choose 2, x2, y2, plus 4 choose 3, x3, y3, okay? The idea is the sum of the powers here, oops, there's one more, then plus 4 choose 4, x4, y0, then there's a mistake here, which should be x, y1, okay? The idea here is the sum of the powers will always be equals to 4, because this guy is 4 here, okay? And by the indexation element, this number here, which ranges from 0 to 4, will always tag along to either x or y, and it will be the same throughout the entire expansion, okay? Can? This one, and then you must know how to evaluate 4 choose 0 or 4 choose 1, 4 choose 2, these kind of things quickly, with or without the calculators actually. And we also mentioned that the binomial theorem is symmetric in the sense that, oh, this can also be seen as 4 choose 0, y to the power of 0, which is x to the power of 4, then plus 4 choose 1, y to the power of 1, and x must be to the power of 3 then 4 choose 2, x2, y2, then plus 4 choose 3, x to the power of 1, y will be to the power of 3, then plus 4 choose 4, x to the power of 0, y to the power of 4, okay? In this case, the same logic follows. So how does this work, right? It's because this term here, 4 choose 0, x0, y4 is the same as this term here. Because 4 choose 0 is the same as 4 choose 0, okay? 4 choose 1 is the same as 4 choose 3, so it's the same as this guy here. And this guy here is clearly the same as this guy here. And then this guy here is the same as this guy here. If you just follow the powers on the algebra, you will see that. Okay, so the formula sheet on the O-level formula, right, will only give you one set, probably the second one, the red one, not the blue one. But when there is no particular, usually the question, right, if it's an advanced question, there is a particular preference one, means it's less painful algebra, okay? Otherwise, if there is no preference indicated, right, I personally prefer the first one because it's easier. Okay, when I write the 4 choose 0 or 4 choose what, I immediately can have the power of x written down, and then the power of y follows through naturally from there. Okay, that's my personal idea. But as you go through more questions, you will actually find your own preference out of these things. Okay, so you never have to refer to the formula sheet for the binomial formula in the actual test or exams. If you have to, right, that means you are still very rusty. Okay, not practiced enough. Okay, so this is the binomial formula. Based on this, it's about how symmetric the formula is. Okay, then last week we ended off with like how to brainstorm for powers quickly without going through expansion, right? So because if you understand the formula, you can actually craft out certain terms quickly without going through any plain point blank expansion. So in this case, for example, if the question is actually asking for x to the power of 7, immediately I know that the formula should be like the term, sorry, x to the power of 2. The term containing x squared should be like 7 choose something, 3 to the power of something, and x to the power of something, okay? Since the question asks for x squared, this guy must be 2. And this guy naturally must be 5, because 5 plus 2 will give you 7. And this guy here doesn't really matter who you follow, so I'll just follow 7 choose 5 then, which you can evaluate on a calculator, and that will be the answer immediately, okay? So the idea here is, okay? Okay, so you should be experts in this. This is still considered very basic binomial questions actually. Okay, any issue on this? Can, right? Okay, so of course, most of the time, it will not be a simple x only, okay? So there's two kinds of extension in difficulty for these things. One could be, it's no longer a plain x, but at the very least, even though it's not a plain x, this guy here does not contain any x at all. So it's still a pure number versus something in terms of x, okay? So in this case, I want x, I have x squared, and I want x to the power of 10. So your lots of indices come in, you know that how to turn 2 into 10, it must be times 5 by the laws of indices. Why is it times 5 and not plus 8, right? Because the term must be 6 choose something again, 3 to the power of something, and x squared to the power of something, okay? So you know that this something here, by lots of indices, this something here times the 2 must give you equals to 10. Okay, by lots of indices. Because x to the power a, b is equals to x to the power ab. Okay, then from here, everything resolves itself. The green box must thus be 5. Okay, if this is 5, then this guy must be 1. Then this guy, since it's 1 and 5, I personally prefer to write 1. Then that's the answer then. Okay, okay. So once again, this guy is 6 minus 5. This guy is 1 or 5. Okay, can follow? So you must be able to work this out mentally, and this is the perfect working already. Okay, but of course, this is the working mark. Then you just evaluate. That's all. Simplify by lots of indices or numerical computation. Okay, can. So this is the considered upside from just now, in the sense that it's not a plain x, but rather it has still an x square somewhere out there. But at the very least, the x terms are concentrated only on one guy only. Okay. So one more step is when there's x on both sides. So in this case, net I want to have power 12. So you know that, okay, I need to have 10 to the power or something, x to the power or something, 3x squared must, and then to the power or something, okay? So this kind of things, like I said last time, there's a lot of mental try and error that you need to come up with, okay? When you cannot come up with a mental try and error right away, right? Just think in terms of like, oh, 5, 5. If I give 5, 5, what will I get? If I give 5, 5, I will have x to the power of 5, x to the power of 10, which is actually x to the power of 15. Okay, and that's too high. So when you split half is too high, right? You must give more firepower to the x term and less firepower to the x square term then. Okay, can follow this one? The idea behind this? Okay, stop me whenever you feel that something is confusing. Yeah.
So wait, just to clarify, when there's two x's, we should just split in half, and then from there, see if we should give more to x or x squared, right?
Okay, if you can brainstorm everything in your head for the right configuration right away, right? Of course, go ahead. Okay. When you are lost, then clearly the trivial case is half.
Yeah.
Because I personally think it will be quite silly if you start from 10, 0, then 1, 9, 2, 8,
Yeah.
8, okay? So 5, 5 will give you the sensing of where to tilt the firepower, essentially. That's my statement, okay? So if 5, 5 is overloaded, I must give 4 here, then 6 here, then, okay? And when that happens, I'll have x to the power of 6 times x to the power of 8, which is 14, which is still too high, okay? Get it? Still too high, then tilt down further, okay? Not even sure whether I'm making a mental mistake here already. So 7, 3, okay? So 7, 3 will give you x to the power of 7, x to the power of 6, which is x to the power of 13. So still too high, okay? Fail. So try again. So you will see that every time we shift, right, the granular power only drops by 1. So eventually 8, 4 is the correct thing already, because x to the power of 8 times x to the power, wait, x, if x is, if 8 here, it must be 2 here. Okay, just now was wrong, okay? So if x8, then this guy must be x4, right? Then net I will have x to the power of 12, and that's the correct answer. Okay, can understand? Then you will have, then this guy, once you have this, then it's like happiness already. Then this is 8. I'll let it be 8 then, okay? Clearly doesn't matter, right? Then simplify and you will have the answer then. Okay, can? So this was until what we covered last week, right? Okay, any questions on this? Anyone? Okay, so there's a lot of, okay, so in this case, this particular method that I'm teaching you has got a lot of mental guess and check. You can feel free to write down your guess and check so that you have something systematic to guide your head. If you feel that you can configure everything in your head, which is what most teachers do when we are solving this kind of questions, go for it also. But that of course takes some time and experience as you roll up your lots of indices and everything at the same time. Okay. All right, Ken, on this. Okay, so today, right, what I want to do is to teach you a slight twist to this kind of question and a new method that Pavin was talking about last week, about something what we call general term. Okay, The first thing is this. So if I use example just now, x plus 3x squared. So x plus 3x squared to the power of 10. So let me see. Okay. So suppose this. The question is this. Prove that x to the power of 3 cannot exist. Okay, in the expansion. Okay, which means that if you actually go and expand out this binomial theorem, right, in total you should have 11 terms because it's power 10. And with the 11 terms, right, all done and dusted and simplified, x cubed will not appear in the expansion at all. Okay. Now, for this kind of question, right, when you are supposed to show that something cannot exist, right, you cannot do the trial and error method then. Okay, because the trial and error method, right, you are supposed to construct it, but you cannot write an answer like, oh, I have done all possible combinations and x cubed doesn't exist. You can't write this in your solution of 10. Okay, you cannot get and write this in your solution and in order to show that x cubed don't exist. Okay, understand? So how do we actually go about showing that this particular guy cannot exist, right? It's as such. So it's something what we call the general term. That means it's like okay, I'll show you in action. So you just write like this general term. So it will be 10 choose r, x to the power of r, 3x squared must thus be to the power of 10 minus r. Okay, to be sure, let me write this r outside the bracket, like this. Okay, Pavan, this should not be the first time seeing this. Any issues with this? Can follow what I'm saying?
Can you like repeat again, like the formula thing is a bit...
Okay, this is actually the general term for the binomial expansion, right? If you think about it, then r can actually be 0, 1, 2, 3 until 10, right?
Yeah.
Okay, can.
Okay.
So what I did was I constructed a general term first. Okay. Then from here, right, you will simplify numbers to one side, things on x to the other side. So this will be like 10 choose r, 3 to the power of 10 minus r. Okay, x to the power of r, x to the power of 20 minus 2r. Can follow? Okay, make sure you can follow first. If you're unclear of the algebra, sound not right away. Okay. So this 3 to the power of 10 minus r, I took it out and replaced it with and took it to combine with the 10 choose r because they are all pure numbers. Okay, x to the power of r is here. Then this x squared to the power of 10 minus r, right, will give you x to the power of 20 minus 2r by loss of indices, which is here. Okay, so basically numbers chucked together, x chucked together. Okay, then simplify, then the numbers here, right, don't have to care anymore. So keep it there for the time being. We will simplify the algebra. So this will give you x to the power of 20 minus 3r by loss of indices. Okay. Can follow so far? Okay. So you can see that I'm just doing nothing but lots of indices only. Yeah. So the question, now the trick to finishing this question is this. The question asks for what? The question asks for x to the power of 3, right? So which means that I need x to the power of 3. If I need x to the power of 3, that means 20 minus 3r. 20 minus 3r must be equals to 3. Get it? Because I want x to the power of 3. Okay? Which means that 3r is equal to 17. Which means that by right, if I want to have, which means that by right, if I want x to the power of 3, right, r must be equal to 17 over 3. Understand? Okay, Yanis can follow. Okay, Yanis, because I cannot see your face because there's no light in your room. So, okay, just take away the speaker and sound out if you have to. Okay.
But wait, but I thought the question is like asking like cannot exist. Then
I know. But if you look at the
that
formula
exist
here, can R actually be a fraction or must R be a whole number?
a whole number.
And yet I say that if you want me to have x cubed, right, R must be a fraction, which is impossible, right?
Yeah.
So and that's why x cubed cannot have exist.
Oh,
And
okay.
then it's like if you want me to do it, I must break the law for you. That's all.
Okay.
Okay, so you can just write therefore cannot exist. Oh, you can just write cannot exist.
Oh, okay.
Okay. Are we okay with this?
Yeah, but for R, right? R cannot be greater than n, and it also cannot be less than 0, right?
Yes, that's right. That's why I say R can only be 0 to 10 only.
Okay.
Okay.
Yeah.
So you must be, so what's the trick to do this question, right? You must be confident in creating the general term first. If you don't even know how to do that, then you cannot solve this question, okay? Notice that in my situation here, right, I let my x here follow this guy here, okay? Could you have done it the other way around, right? That means you let x be 3x squared and 10 minus r be x, okay? That means you swap the powers between these two guys, okay? If you choose to swap the powers between these two guys, right, you will have the same result. That means you will actually still get R to be a non-whole number, and that proves the thing also. Get it? It's just that maybe your R value will not be 17 over 3. It might be something different from me, that's all. Okay? But you at the end of, but that's not the point here. The point is you will still get R to be not an integer, and that's the whole key to this question. Okay? In fact, when I purposely let this guy follow this guy, right? It's because that's my preference. Like I said, my preference is always the first term of the binomial, right, will follow the index element, which actually, in this case, right, if you let this guy be R, right, it's actually more efficient because less painful algebra to deal with. Because this guy is like x squared coupled with it, more compounded indices, that's all. But it's not detrimental, okay? So you must be flexible in both ways. That's where your algebra will improve actually, okay? Can follow? Can? So this method, right, actually can be used in all the questions here that we have covered above, this kind, okay? Or even this kind. Of course, this kind, I think it's quite stupid if you choose to use it, all right? It's inefficient, okay? But this kind, sometimes you can actually use it to streamline your thinking. So what do I mean by this, right? Just now was x to the power of 12, right? Okay, then x plus 3x squared to the power of 10. So I'll show you how to do it. Okay, so x plus 3x squared to the power of 10. Then the thing is 1x to the power of 12, which means that I will simplify and then let the power of x be 12 at the end of the day. That's all. Okay, so you just write general term. So it's 10 choose r, x to the power of r, 3x squared to the power of 10 minus r. Okay, so you must be confident in crafting this, of course. Then simplifying this, we will have 10 choose r, x to the power of r, 3 to the power of 10 minus r, x to the power of 20 minus 2r. Okay, so remember, this came from this. Okay, the 3 has to be removed from the situation. So then combining all the x and combining the numbers, 3 to the power of 10 minus r, then this will become x to the power of 20 minus 3r. Wait. 20 minus r. Okay. Then I made a... What do I feel I made a mistake? Oh, shit. Okay. There's a slight mistake here. Sorry, you guys. So it's 20 minus r actually. Correct? Agree? Because of this, what's happening today? This guy here, okay? 20 minus r plus r is 20 minus r. Okay, so but it's the same conclusion. So 20, I need 20 minus r to be equals to 3. So r, how can r be 17? Oh. So r is equal to 17. Impossible. Okay, because r can only be between 0 to 10. Okay, sorry for the mistake. Okay, so coming down to this, based on this, I want x to the power of 12, right? So this just means that I need, then you just write need 20 minus r to be equal to 12 because it's this guy. Okay, then 12 is this guy. And then from here, so r is equal to 8. And 8 is actually a legitimate value here. Okay, so under here, r can actually be 0, 1, 2, dot, dot, dot until 10. So r can be any integer between 0 to 10. And if r is 8, I will jackpot already. So, okay. So you will just write x to the power. So x to the power of 12 is when r is equal to 8. So you will just say x to the power of 12 is 10 choose 8. 3 to the power of 10 minus 8. And x to the power of 20 minus 8. Then simplify. Okay.
Is it possible for the question to ask you instead of like solve for x to the power of 12? They
Sorry?
ask you to solve for the coefficient of x. Like they say, for example, find the power of x when the coefficient of x is 10, for example.
It's possible also.
Oh,
Okay.
okay.
Which means that you will equate, let's say you want a coefficient to be 2000, right? Then you will
Yeah.
equate this to be 2000 and then solve for, attempt to solve for r then.
But then how do you solve, because it would be 10 choose r, so how do you solve for the r?
Yeah. Try and error on a calculator actually.
Oh, okay.
Yeah. Because you do not know of any algebraic way to solve this elegantly yet.
Oh, okay.
Okay, so just use a calculator, scientific calculator and try. And as you know that r must be a whole number, right? And they're not going to give you numbers like r is 365, of course, okay?
Yeah.
Maximum power 6 or 7 only. Okay?
Okay.
So the reason why I did not go through this method last week, right, is because I feel that it's important to train your brain, right, for this chapter to think in terms of this kind of things. The trial and error pattern, okay, to process it in your head in the lots of indices. It's very important, okay? So this general method, right, though you feel that it's very legit and everything, right, but it's very prone to carelessness, at least for students in this kind of section here, okay? So try not to use this too often. My rule of thumb is I will only use this method when the question is asking me to show that something cannot exist. Okay, because to show that something cannot exist, R would then be a number that's beyond the situation one. Okay, namely a fraction or a number bigger than n, which is impossible. Understand? Can? Okay. Any questions on this, guys? Yanis, anything?
Okay.
Okay. Okay. Okay. So we have a few other extensions, mainly two. So a few other things that you just need to be aware of. That's all. Okay. So let's say Pavan also asked this question: what if it's not binomial? What if it's trinomial? Let's say the question is 1 plus x squared to the power of 7. Okay. But you know that you only know binomial, right? You do not know what's we do not have a formula for trinomial, right? So the point is you must turn this into a binomial situation. So how to turn this into a binomial situation, right? There's only two ways, okay? You can turn it into like, 1 plus x squared to the power of 7. Or 1 plus x squared to the power of 7. Okay? Usually a trinomial means 3 terms. A trinomial question will not appear from nowhere one. It will definitely appear for a particular reason, and then there should be a earlier parts guiding you to what to do already. That will have given you advice on whether should you go for this one or this one. Okay. Okay. So let's say if you go for the first one, right, then this is just your A, this is just your B. Okay. But if you go for the second one, clearly this is your A and this is your B. Then classic binomial expansion and expand and simplify again. Understand?
Is it an option to factorize the trinomial?
Try not to. I mean, usually if that happens, that usually won't be part under the binomial question really, or it's a very special niche area that I don't know want to really cover this in our video lessons like this.
Okay.
It must be a particular special kind of question, but not officially like stated under the syllabus then. Okay.
Yeah.
So I'm just all these video lessons, I'm just trying to give you all the essential skills, all the like various special level 99 side quests we have to go through it when we see it rather than me teaching it for the sake of teaching it actually. Okay.
Oh, okay.
If you have this kind of special request, feel free to send it over, then I'll go through it in class actually.
Yeah. Okay.
Okay. Okay, so understand on these things. Okay, so to prove that something cannot exist, and when you need to try and error, okay, and a general term. If you can master this, 80% of the binomial questions you can do already. Okay, can? Okay, so what will be the typical exam questions, right? So it will always be like this. So they will be like, oh, maybe this is 1 plus x times 3 plus x. Let me keep it simple first. 3 plus x to the power of 10. Okay. Then they will say, find x to the power of 7. Okay. Okay. So if you see a question like this, what should you do right away first? What do you think you will approach this question?
Do we like expand out like the binomial thing first, like the to the power of 10
Okay.
that bracket?
So remember, for a binomial question, right, at the advanced level, you are actually never supposed to expand out the question one. Okay. Yeah, you are supposed to always use the thinking that we have been covering in the last lesson and today, right, to go and pinpoint a particular power that you need. That's all. You're never expected to expand out one. Okay. Imagine this question, I give you power 100. Are you going to extend power 100? Cannot be, right?
Oh yeah, okay.
So to expand is correct, but it's not a scalable method. Okay. So if you think about it, this is a multiplication of two polynomials, right?
Yeah.
And you have already went through polynomials already. By the way, Pavan, have you went through polynomials in school?
You mean like the comparing the coefficients? And
Yeah, and remainder factor theorem, long division of polynomials.
Yeah, but like we did it quite long ago, so I don't really remember it.
Okay.
But yeah, we went through it.
Okay. So Yanis, if you look at this is a multiplication of polynomial, right? So if you look at these two products, what do you think are the multiplications that will contribute to x to the power of 7?
The 1.
Okay, one on the left, right? Correct?
Yeah.
He must look for what power here in order to get power 7?
X.
He must look for x to the power of what?
X to the power of 7.
He must look for x to the power of 7. Understand? And do you think x to the power of 7 is a power that is present in the second bracket?
Yes.
Yes, okay. Okay, and then on the other hand, the x, this guy here?
3.
3? No. If I expand on the second bracket, right? Which power within here is going to couple with this x to give you x to the power of 7?
3.
X to the power of 3?
No. X, the x also.
No, but x to the power of what? If I actually expand this out in the binomial already, I will have all kinds of x powers lurking in the expansion, right? Then which x power will couple with this guy to give you this guy?
6.
It's 6. That's what I meant. Understand?
Okay.
Which means that the 1, right? This guy here, he's going to look for the power 7 inside here, the red arrow, okay? Whereas this guy here, he will be looking for the power 6 inside here, the purple arrow. Understand?
Okay.
Okay. So with this in mind, right, you will then know that I actually only need the power 6 and power 7 from the binomial. Get it? So do you actually need to expand this out then?
No.
So once you have this in mind, right, the question boils down to looking for x power 6 and power 7 under this guy then, okay?
Also, we have to like separately find 6 and 7.
Which is actually part of the official presentation of the solution. I don't just check it out at one column actually.
Okay.
I'm writing it here because I want to like let you see everything in one screen. That's all. My screen is too small already. Okay. So under here, if I want x to the power of 6, okay, Yanis, how should I get x to the power of 6 then?
10 bracket 10
Uh-huh.
and then 3
Okay, 3 must be to the power of what in this case?
4.
4, then this guy must be 6, okay? Then this guy will be 4, then, okay? Can? Then,
Okay.
okay, so a reminder, in the second one for x to the power of 7, you cannot go and write 10 choose 7 right now. You must follow the first guy. Because this guy here, right, I already showed that this guy is always going to always be following this guy. Okay, so you should follow suit in the second situation. Okay, so let me just grab my calculator for a while. Okay, so 10 choose 4 times 3 to the power of 4. Okay, which means that my x to the power of 6, right? X to the power of 6 is actually equals to 17010 x to the power of 6 actually, okay? If you press the calculator and evaluate it, you have the same answer. 10 choose 3 times 3 to the power of 3 times 3, 3240. 3240 x to the power of 7, okay? Let me just double confirm the same. Okay, can? Okay, so once this is in place, right, the solution becomes, the question actually can be seen as this. This guy, this entire guy here, right, 1 plus x is always going to be there. No matter how you do, 1 plus x will just be 1 plus x. Nothing is going to change, okay? And as for the binomial, right, all other powers are irrelevant except for this power and this power, as we have achieved from the brainstorming, right? Which means that you can just write this. Oh, dot, 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 dot. That means it's like I have pretended to expand already, but it's just dot, 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 and then nothing else matters but 17010 x to the power of 6 plus 3240 x to the power of 7, like this. Get it? Okay? That means the got power 1, power 2, power 8, power 10, all don't matter to me. Only 6 and 7 matters to me because the question asks for x to the power of 7. Okay? So, and then from then, you will know that, oh, which means that x to the power of 7, right, is achieved by 1 times 3240 x to the power of 7 plus x 17010 x to the power of 6. Okay? Even though this product got more things, right, like this guy here multiplied with this guy here will give you x to the power of 8. But that's not my concern in this question. I only care for the things that will contribute eventually to x to the power of 7. Understand? Calvin, okay with this? Yanis, okay with this?
I think so.
Okay. This is the first time you are seeing this. So maybe my presentation is a bit too loosey-goosey and sluggish here, but the idea is there. Understand?
Yeah.
Essentially, you only want the products that will contribute to x to the power of 7. Okay? So you can see this chapter relies heavily on your being able to do the lots of indices quickly in the head, of course. Okay?
So we can just like take away the x for the x to the power of 7.
Yes, yes.
Like we don't
It
need
depends on the
to
question.
calculate.
If the question asks for the coefficient, then take away the x, of course.
Oh,
If
okay.
the question says give me the x to the power of 7 term, then you have to just evaluate this and then whatever, then x to the power of 7 will do. Okay?
Okay.
Okay, can? Okay, so things, okay. If this was a nicer binomial question in the actual exam, right, there will be multiple parts, okay? The first part, right, they will tell you to focus on this guy only, okay? Then they will say, can you tell me what is the x power 6 and x power 7 inside here? The green one. Okay, that will be your part A and part B. Then the part C will say, now look at this guy, entire guy, and tell me what is the x to the power 7 term, that's all. That means they are already giving you they're helping you in the brainstorming process already. Okay. Understand? Give me a minute, sorry. Okay, Calvin, okay with this? Is this any way different from what I taught you? I mean, your teachers taught you?
My teachers, like, she didn't go through, the way she did was she just expanded the whole thing. Like, she just, the whole, she just expanded until she got to x to the power of 7.
No, okay. So stick to this method. Okay, you are supposed to be able to brainstorm in advance. That's what the essence of binomial theorem is. Like I said, to do pin expansion, right, is actually okay, but it's not a scalable method. If this was power not 10 but power 100, you will die already. Okay.
Okay.
Okay. So Yanis, okay, don't never. I never want you to expand one. Okay. You will never have to expand any binomial theorem question unless the question literally say expand. Okay. Of course, like I said just now, the part A, part B, right? The part A could have been like, oh, go and find the x power 6 and x power 7 first, right? Alternatively, another way of them trying to help you, right, is to say expand 3 plus x to the power of 10, expand until the x to the power of 7 term. That means they are helping you in the expansion. Then that one, you have to do the expansion process. Okay, because the question forces you in the direction. But that kind of question, not good questions. That's all. Okay? Can? So I never want you to do labor work on for this kind of things. All right? Can? So just about 20 minutes left. So you just do, you just go through some of this together, okay? So if I say x squared plus 3 over x, let's say 4 plus x to the power of 10 again, then I want x to the power of 3, maybe 5 then. Okay, so Pavan, you take this. So what do you think are the steps that go through in your head when you come to this?
First you have to do the 4 plus x.
Okay.
Oh, wait.
Okay, to be frank, so let me just share my personal habits first. When I see something like this that I don't like to see, right, I will take it into negative powers first.
Yeah, I put it as 3x minus x, 3x, and then x to the power of negative 1.
Okay. Do that. Always do that as the first thing, right?
Yeah.
Okay, so within the second brackets, what should be the priority then? Or what?
Finding, because, you know, but then when you expand it, the 3x minus 1, it would become a negative number, a negative power.
It will be a negative power, which means that who will be his partner here to give you x to the power of 5 then?
So it has to be 6.
That's right, okay. That means this guy has to look for power 6.
And then the x squared will have to look for power 3.
Power, yes, that's right, okay.
Yeah.
Get it now? Okay.
Yeah.
Okay, so you would then tell me how to, I mean, pardon my writing. So 4 plus x to the power of 10, I need the power 6 guy and the power 3 guy. So you will tell me who they are.
So 10 choose 6 times 4 to the power of 6. Oh wait, times x to the power of 6.
Okay.
And then times 4 to the power of 4.
Okay.
Then for x cubed, you would do 10 to the power of 3, x to the power of 3, and then 4 to the power of 7. Then solve with the calculator.
Wow. 1966080 x to the power of 3. Okay.
Yeah.
Okay, so what we are saying is only these two terms matter to us in the expansion of 4 plus x to the power of 10. So the question now becomes a situation of x squared plus 3x to the power of negative 1. Then you can just anyhow write dot 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 first. You can write dot 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 in front or behind, up to you. Then plus 1966080 x to the power of 3 plus 53760 x to the power of 6. Okay, they are not in sequence, but it doesn't matter. Okay, Everything
Yeah.
else is just chucked under the dot already.
Yeah.
Okay. So then I want x to the power of 5. So ask yourself which pair of products matters. So it must be x squared be with this guy here. Okay. And this guy will be with this guy here. So remember, the power -1 in this case only applies to x, not in 3. 3 we should
Yeah.
keep up there. Coefficients never adjust anymore. Okay, only adjust the powers of x will do when you see them in the denominators and stuff like that.
Okay.
Okay.
Five, three, 7, 9, 7. So then you need to do, so then it would just be 1966080 x to the power of 5 plus 53760 times 3, which is 161280.
Yep.
And then your final answer would just be 1986080 plus 161280, right?
Whatever it is. Okay.
Yeah.
Okay.
Okay.
Understand?
Yeah.
Yen's okay with this?
Yes, I'm still like digesting it. I think should be okay.
Make sure you are okay with this first. So you just look at it first, okay? Anything you're not sure, just sound out first, huh?
Okay.
If the problem asks for like the coefficient of solve for the coefficient of x to the power of 5, right? And my final answer, let's just say I'm careless and I write whatever the answer is, x to the power of 5. Will I not get the answer mark because I wrote x to the power of 5? But because it only asks for the coefficient. So will I get?
Probably take away 1 mark actually to be strict.
Oh, okay. But if the answer mark's worth like 2 marks, then I still get 1 mark, right?
Answer marks will never be worth 2 marks.
Oh, it's always worth 1 mark.
So A math mark or O-level marking scheme only got 3 marks, 3 types of marks rewarded. 1 mark for method, 1 mark for having the correct numerical answer, and 1 mark for like those genius idea marks. That's all. Sometimes where you don't show any methods.
Yeah.
Okay, so it will never be an answer that's worth 2 marks actually. If something is worth 2 marks, right, that means it's 1 mark for method, 1 mark for your answer.
Oh, okay.
And the method must be, to earn the method mark, you must convey the idea through your working. That's all.
Yeah. Okay.
Okay, Yanni's okay with this?
Yes.
Okay, so you will try the next one. Okay, so let's say if I have 4 over x squared plus x. Okay, this will be a bit more hardcore, so slowly. Then x plus x squared, x plus 3x squared to the power of 10 again, okay? Then I want x to the power of 7. Maybe not 7, it should be more powers actually. 14 then, okay? Okay, so just run through with me your idea and then slowly, okay?
So is it like we change the fraction to a whole number?
Okay, how about you rewrite the thing first?
For x to the power of -2 plus x, and then they are the same thing. and then like we have to find like to the power x to the power of 14.
Okay. And then,
So the 4x to the power negative 2, you have to find x to the power of 16.
okay.
And then the x, you have to find x to the power of 13.
Okay.
So do we like how to say continue like x to the power of 16 and x to the power of 13, or
Yeah. So okay, x to the power of 16 first then.
okay. So x to the power of 16 is bracket 10,
Uh-huh.
and then yeah, 10, and then after that bracket x and bracket 3x square.
So 10 something. So what do you think it is?
uh
For this problem, right?
Hmm.
Because you need to solve for both x squared for the x squared part, and then you also need to solve for the x, right?
Hmm.
Oh, okay. So in the end, like towards the end of your workings, you would have something x to the power 14 plus something x to the power 14 plus something x to the power 14 plus something x to the power 14.
Mhm.
Okay.
Okay, Yanis, how should I split the 10?
wait, I did something wrongly. Oh, 4 and 6.
Good. Okay. So it's 4 here, 6 there. I'll just pick 4 here, okay? So that will give me 3 to the power of 6. Times 10, choose 4. So this will give me 153090 x to the power of 16, okay? So this is x to the power of 16. Or x to the power of 13. So x to the power of 13 is actually a power that doesn't exist. If you try out all, I don't think it exists. Okay?
Sorry.
I don't think x to the power of 13 actually exists in this case.
Ah,
Does it?
as in,
No, this guy, x to the power, so x16 is settled already, right?
yeah,
I don't think x to the power of 13 actually exists. Do you have our number to it?
not yet.
Okay, so let's try, okay? So now I want you to try to prove that x to the power of 13 don't exist.
Oh, okay. So, so we have to do the what's that called?
So how do we go about it?
Use the general term thing.
How do I write it out? Just say it and I'll do it.
10,
Hmm.
choose R,
Good. And then
to x, choose R,
x to the power of r.
x to the power of R, and
3x squared.
3x squared 10 minus r.
Yeah, okay, good. Okay, and then what you do next?
And then we split it out to x choose r, and then 3 to the power of 10 minus r, and x to the power of 20 minus 2r.
Okay. X to the power of 20 minus 2r. Okay, and then?
And then after that, combine the both x's to become 20 minus r.
20 minus or 20 minus r. Oh, actually it exists. Oh, it exists. 20 minus r. Okay. So r is 7. 7. Oh, yeah. Okay, it actually exists. My mistake. Okay, can. Then, so now need what? What do we do then? 20 minus r must be equals to
Uh, 13.
13, okay? Which means r is equals to 7. So it actually exists. Oops, my fault, okay? I purposely gave an odd number thinking that it won't exist really. So if you can do this, also can. That means you know that r is 7, right?
Yeah.
Immediately push 7 inside here will do, okay?
Oh, okay. So it's 10 choose 7 and x to the power of 7, 3x squared to the power of 3.
Okay.
Okay.
So give you 10 choose 7 times 27, giving you 3240 x to the power of 13, okay?
So then after that, we just like continue like the bracket, put the bracket 4x to the power of negative 2 plus x, and then you bracket, then you dot, then you add both inside.
Plus x, then dot, then plus 1.
For this one, do we need to go in like, we don't need to go in like the x to the power of 13 first, right?
No need. Say that again. No need. It's up to your individual preference. How do you want to write it on?
Oh, okay.
So the final answer is just okay. So even write equal, right? So I'll just write arrowhead. So the question asked me for x to the power of 14. So it's actually 4153090 x to the power of 14 plus 3240 x to the power of 14 will do. Okay.
Okay.
Which is equal to 615600 x to the power of 14 then.
Okay.
Understand? Okay.
Yeah.
So if you can do this practically completes your binomial theorem already. Okay.
Oh, okay.
Understand? So you must be confident on how to do this and watch out for the powers and prove that something don't exist. That's all.
Okay.
Okay. Alvin, okay with this?
Yeah.
Are there any questions from your school's experience that you feel that I didn't cover yet though?
Not really, because I remember the last thing my teacher just did pretty much what they're doing, then she just did trinomial, then we were done with the chapter.
Okay, no. Okay, so trinomial is a special case, like I said. It's
Yeah.
just split it up properly. There's no, I cannot give you a quick special trick offhand. I need to see the question.
Okay, sure.
So
I
if
can send it to you later.
okay, that will be good.
Yeah.
Okay.
Okay.
Okay.